here again. Welcome to this video about how I'm going to try and do a DIY install of some LEDs into my lovely new Audi Quattro rally body. As if you followed the other videos, you'll see that this does come with the light buckets for the front and for the rear, and it comes with these 6 spotlights that go on the front, but these aren't ready for LEDs, they're just blanks. So what I've done is I've drilled some 3mm holes in the back, I don't know if you can see, all the way through. So now hopefully I'll be able to put a 3mm LED into those. So that's the plan. I've started off looking at using the Tamiya TLU unit, which I've got in this Mitsubishi Lancer shell. This came with the kit, this TLU, which is the controller unit, and it came with the 2 lights for the front and the 2 for the rear. Now I've priced this up on the internet. This is £40+ and just a pair of LEDs is over £10, so that's £60. And if I then add 3 pairs of white LEDs for the spotlights, we're getting on for £100. So that was a no-go. So I looked around, and you can also get much cheaper light sets, LED sets with a controller, but none of them did what I wanted. I just want a simple setup where I can put this onto my TTO2 and turn all the headlights on, all the spots, and have the rear lights running. I don't want any indicators, and there's nothing with that specification. There's nothing with the 6 white LEDs for the front, 2 headlights and the 2 rears. They were all indicators, stop lights, reversing lights, and so on. So I thought I'll have a go at doing my own. So I've done a bit of research, and I've bought a few cheap LEDs. These are cheap as chips. I think I paid about £5 for the whole lot. I've got about 40 LEDs. I've got a bunch of 3mm LEDs, a few 5mm LEDs, some red and some white for the headlights and the tail lights. And I bought some resistors. I think these were about £1 for 20 or 40. So very cheap. Now I've got to work out how I'm going to wire it up. So basically we need to do a bit of Ohm's law, which is, well, I know is V equals I times R, which is your voltage equals your current times your resistance. That'll come in handy in a minute. So I know I'm running off a battery here, which is this, which is 7.2 volts. So I need somehow then to wire that up to some LEDs. Okay, the LED symbol is something like this with 2 little arrows. Okay, that's one LED. Now my LEDs are rated at 3 volts. So what I thought I'd do was connect 2 of them in series, like so. And that'll give me 3 volts and 3 volts, which equals 6 volts. Now I did a bit of checking with my multimeter, and these LEDs that I've bought, both the 3mm and the 5mm, actually drop, so I'm going to rub this out, 2.8 volts, if I can write. So that's giving me a total of 5.6 across the LEDs, which leaves me with an extra 1.8 volts that I've got here. I need to get rid of that, and the way we get rid of that is with a resistor. So I need to work out what resistor I need. Now when we're talking about electrical circuits, we need to look at the maximum things that we might expect. I've checked my battery, this nickel metal hydride, and it's actually putting out 7.4 volts when it's charged, fully charged. So I need to take that into account. And I checked a couple of others, and when they came off the charger, they were putting out 9 volts. So we'll have to cater for 9 volts. But first of all, I'll work out the resistor I need if I'm putting out 7.4 volts. So let's just rub this out. V equals IR. I'm going to transpose that now to the resistance. So the resistance equals voltage over the current. So I've got 7.4 minus the 5.6 for 2.8 plus 2.8, which gives me 1.8 volts. That's how I've worked that out. So resistance, the resistor I need is going to be 1.8 volts divided by the current, and the current rating of these LEDs is 20 milliamps, which is 0.02 amps, and that equals about roughly 100 ohms. Okay, so we're looking at about 100 ohm resistor I need to put into this circuit. Now, if I take the maximum voltage we can expect, which is going to be 9 volts, that changes quite significantly. I'll just push this up out of the way so we can see. That then changes to, that'll be 9 volts minus the 5.6 drop from the diodes, which gives me 3.4 volts. So if I then use that onto this equation, I've got 3.4 divided by 0.02, and that equals 170 ohms. So that's the maximum kind of resistor I can expect to use. Checked around, and one of the closest values to that I could get was a 220 ohm resistor. So if I rub that out, I'm going to do the resistor sign, and that is 220 ohms. So to make sure that these calculations are actually correct or okay with the components I've got, I made up a little test circuit. So I've got my battery connector. I'm going through a little connector there that I can use to unplug the light system from the chassis when it's finished. I've got an on-off switch, and then I've got my little test rig here. So as it shows in the diagram, I've got positive wire, I've got the 220 ohm resistor, then I've got 2 of the LEDs in series to the negative wire. If I hold that a bit closer, you might be able to see better. So the resistor and the 2 LEDs, and then what I've done is I've put in parallel, so running alongside that, you've done the 3 mils and the 5 mils, so 220 ohm resistor and then the 2 3 mils in series. So if I just turn this on, you can see that, whoa, it hasn't blown up. The LEDs are actually quite bright. There's a lot of background lighting here, but you can probably see on camera that they actually are very bright, both the 3 mils and the 5 mils. So that looks like the calculation works pretty well. I can get them to go brighter if I put another resistor in parallel with that one, which basically halves the resistance down to 100 ohms, but I'm happy that's bright enough. And I have had this tested, this test rig left on for 2 days constant, and there have been no problems. Nothing's broken down, nothing's melted, nothing's overheated, so I'm confident that that's gonna last quite a long time. So all I need to do now is to take this idea and put it into practice in an actual wiring loom that's going to go into my body. So I've drawn out the wiring diagram for all the 10 LEDs that we're going to be fitting. We've got the battery here, got positive on this side, we've got negative on this side. So we go first for positive. We've got the 2 LEDs in series with the resistor for the headlights. We've got the 2 clusters of the spots. What we're going to have to do here is we've got the resistor and 2 in series for this side to negative. Same for the other side there with the 2. But for the third one in each of the clusters of spots there, I'm going to have to split that with a piece of wire between the 2 spot units. But yeah, that should be quite easy to do though, really. It shouldn't be too tricky. And then lastly, we've got coming down to resistor and the 2 LEDs in series for the tail lights, which will be LEDs. Now I know I was going to try and get this all done in one video, but as usual guys, I've gone on far too long. So what I'm going to do is I'm going to show you what I'm going to use. All I'm going to need, I think, is some solder. I've got a gas soldering iron, which I might be using. I do like that. I've got a bunch of wire that I've stripped out of some computer cable. I've got the LEDs and resistors. All important heat shrink that I'm going to need to seal those soldered joints. And I think all I'm going to need on top of that are a nice sharp pair of cutters. So once again, thanks very much for following along. Hopefully you'll join me on the next one, where we'll get all this stuff finally installed into the Audi Quattro body. Cheers guys, bye.